So you're buying a new graphics card. How do you pick one?
Hi, I'm Paul, this is Diane, and we are the PC Zombies.
And today we're going to cover the key tricks to buying a graphics card.
I'm going to start by talking about the requirements, like do you even need a graphics card? And if so, how much speed do you need? How much memory do you need?
And Paul will cover the technical issues such as the PCIe and the power supply.
And after that, we're both going to cover aesthetic issues such as RGB lighting and color. They do actually change the brand you pick sometimes. We'll also talk about the size of the graphics card, how that affects the decision, and if you decide to do water cooling on the graphics card, how that could almost completely change how you shop for that card.
And we'll end by showing you how to actually shop for a graphics card on Amazon.
So let's get to it.
All right, the first step is to assess your GPU's performance.
Your GPU is your graphics processing unit. Now that's different than a graphics card because in your current PC, you may not even have a graphics card. So here's what I want you to do. Hit Control-Shift-Escape on your keyboard. That brings up the Task Manager. The Task Manager will show you if you're having a performance problem with your current graphics processing unit, which may be on your CPU, it may be a separate graphics card. Click on the GPU graph. You may have two of them. Modern PCs typically do have at least a GPU on the CPU. Some CPUs don't come with it, but most of them do. If you do have a separate graphics card and you know it, you probably also know it's an NVIDIA or an AMD graphics card. Try to pick that one if you can. Now to access your current performance, because when you buy a new graphics card, you want to at least get what you have already plus extra performance if you need it. Go to Google and Google what are the key specs for and then put your GPU name there. So in my case, NVIDIA GeForce GTX 1070. If it's a CPU GPU, just put it in, that works too. Take a screenshot of these values or document them like I have done here. By writing all these things down in advance, we're gonna make sure when we actually shop for a graphics card that we don't actually go backwards in terms of capabilities. And we also know if we find we need more memory, we know what our baseline is. We also know if things are gonna be compatible. If we're gonna put the new graphics card in the same machine, we need to know what the power connectors are and that the power supply can work with it.
The second step is to see if you need more graphics capabilities.
Don't stop the Task Manager yet. Control-Shift-Escape if you brought it down, because you want to keep that up and you now want to look at what is slowing down your PC in terms of graphics. Because you already have a GPU somewhere in your current PC. It's either on the CPU or you have a dedicated graphics card. If your current PC doesn't even have a graphics card and you're not bottoming out, don't buy a graphics card.
Yeah.
But if you do need a graphics card, this analysis will help you understand if you need one with more memory or more speed. And the best way to do that is to find the tasks on your computer that are slowing you down. For example, in my case, video editing tends to always kind of max out. It may be my graphics card, it may be my CPU, but the Task Manager will tell us. In your case, it may be gaming. Go into those apps, get to that point where you feel like your computer's getting bogged down, and then look at the Task Manager and see if there's anything maxing out. In the case of memory, if that's maxing out, we're gonna make sure that we write that down and we know whatever our old number is, in this case it was 8 gigabytes, we need more in the new graphics card. In the case of speed, if it's something like any of the top graphs are maxing out, like in 3D performance, video encoding and decoding, any of that's maxing out, you probably want to get a graphics card with more cores or a higher boost clock.
The third step is to assess your PCIe requirements.
Now your motherboard actually has two PCIe controllers on it. One on the CPU and one on the chipset. In most cases, you want things that have to be fast like graphics connected directly to the CPU. And in general, most motherboards have like 1/16 lanes going straight to the first slot, and that's for the graphics card. The chipset typically is used to manage slower peripherals, like your SSDs, but if you want your CPU to have direct access to the graphics card, especially if you're playing a game or something. So the way we do this is that we look up the tech specs of the motherboard that you're going to put the graphics card on. If you're just upgrading your current PC, it's your current motherboard you need to look at. If you're building a new PC or buying a new one, look up the motherboard on that PC. When you get to the website or the manual for that, you want to look up PCIe or expansion slots, and you'll find a section that describes the specs on that. Now, as far as PCIe goes, this is the big slots that you're going to hook the graphics card into on your motherboard. And so when you're looking at the tech specs, you're going to see several different things. One is how many lanes are on the slots that you have. And you're going to also see that some PCIe slots are attached to your CPU and some are attached to your chipset. So you want to find out the ones that are going to your CPU, because that's what you want. You want fast performance between the graphics card and the CPU. For example, my motherboard says I have two X16 slots. That means there's 16 lanes and one X4 slot. The X4 connects to the chipset. I'm going to ignore it. The two X16s run at version 5 PCIe. That's great. But there's this little tiny note here. You don't want to ignore these little tiny notes. Mine says that if you hook up an SSD to this one SSD slot, it will turn off the second X16 slot and take half of the lanes away from the other X16. So that means my graphics card's only going to get half the number of lanes and half the bandwidth. The second compatibility thing about PCIe is the version number. Each version of PCIe is twice as fast as the previous version. That's a nice standard, because that means if your last computer had PCIe 4 and this one has PCIe 5 and you can find a compatible PCIe 5 graphics card, you're going to have twice the speed going to the CPU.
I could understand that last part because of how you said it was twice as speed. Every version's twice as fast.
Easy? Yeah. And then when you actually shop for the graphics card, what you're taking away from all this is you want to buy at least the same or less version number, and certainly the same number of lanes that you have the capability of on your motherboard. So for example, you don't want to buy a PCIe 5 graphics card and try to put it in a computer that only supports PCIe 4. If you do, you're going to lose half your bandwidth. But it is okay to buy a graphics card that's PCIe 3 and put it in your computer. You're not going to get as much speed as you could, but maybe that's what you can afford, and maybe that's what you need, and maybe that's better than what you've already found you already have, so it's okay to do it.
The fourth step is to decide your power supply needs.
There's two ways to look at this. Are you upgrading your existing PC or are you building a new one? If you're upgrading an existing PC, find out what the wattage of your power supply is and make sure you get a graphics card that won't overdo that wattage, giving yourself some bandwidth for the other components in your PC. You also want to make sure that the power cable to the power supply will work with the new graphics card you buy. If you're building a new PC, now you can buy whatever power supply you want, but beware, high-end graphics cards require an awful lot of power, and so you may need a very powerful power supply and also maybe a more modern connector to get to the graphics card to supply that power. For example, on my latest builds, here's the power supply analysis that I did. And what you see there is I've accounted for the CPU, the SSDs, and other things that are in there, but the number one thing that's using all the power is the graphics card, 850 watts. My total comes out to around 1500 watts.
Wow.
I need at least a 1500 watt power supply and probably more just to give myself some headroom in order to run this computer.
Next, match your monitor requirements.
If you have multiple monitors, you might need multiple connectors on the back of your graphics card. Don't forget, you might also have a connector on the back of your motherboard from your CPU. You can use that for a light monitor, just like HDMI running spreadsheets and things like that. But if you have a big monitor, like for a gamer, and it has a high refresh rate and a high resolution, you want to look up that as well and make sure that the connectors on the back of the graphics card are also the right kind. If you've got a display port cable only from your monitor, make sure there's this display port connector on the back of the graphics card.
Number 6 is checking to make sure that the graphics card isn't too big.
The size.
Yeah.
Graphics cards can be very big nowadays. Sometimes maybe your PCIe slot will take it, but something else on your motherboard or something else in your case is going to be in the way. Graphics cards come in all shapes and sizes. The really high-end graphics cards come in very big shapes and sizes. Sometimes they have 3 fans to cool the graphics GPU inside of them. In this case, it's got to fit across the motherboard, maybe past the end of the motherboard and into your case. If you know you got a really big case with lots of air and room, you're probably fine. Now, if you're planning on buying a small case, be very careful to measure out what your graphics card size is and make sure that it'll work, including what you may need to plug in the power to the graphics card, because that's going to be sticking up as well.
The 7th step is deciding any aesthetic issues.
In the case of your standard graphics card with an air cooler, the air cooler may have RGB lighting in it, like this has some around the end here. But for me, in terms of RGB, it's the management software. That means the most. And so I've always talked about this, but basically I don't want to manage my lights in 3 different applications. I want to manage it once and forget about it. And so buy one that matches something that you know you're already using, like the brand of your motherboard or the brand of your memory or the brand of your fans, whatever else that may have RGB in it. In terms of color, you can buy a white, a black. In fact, graphics card, it's just the air cooler's a different color. This one's white. Maybe you could buy one that's, got even other colors like red or whatever. So it's just about aesthetics. So buy what works for you. What do you think, Di?
Pink.
Would you put a black graphics card in a white build or a white graphics card in a black build?
Yes, it's a personal choice. You may decide to put some black and some white, but make sure that you balance it out. And I usually like things in 3.
Wow. So graphics card, memory, maybe fans.
Yeah, there you go.
Okay.
Step 8 is to consider how you're going to cool your graphics card.
If you're doing air cooling, you're already covered. Most graphics cards come with 2 or 3 fans and they're already ready to do all the air cooling. They have the radiators and everything built in. But if you're doing water cooling, you have a whole bunch of different options and it even changes some of your requirements. By water cooling, what I mean is you can actually buy a water block, which will take water and put it closer to your GPU on your graphics card, and then supply that water from a system like a custom water loop. Here's an example. This is the cooler I've taken off of the graphics card. If I kept this on and I air cooled the graphics card, this cooler would have to take room on top of the motherboard and inside your case, and it's extremely long as well. All that to air cool it, and it may be noisy. With water cooling, I was able to put a water block. And what that means is water comes in one of these pipes and then back out the other one, and I just keep sending cold water in. The water will circulate right above the chips. It keeps the graphics card nice and cool, and it doesn't need to be as big. It doesn't need built-in fans. That's happening from the radiator that's cooling the water coming through the pipes. So in a custom water loop, your graphics card can be very, very advanced, but not very big.
Cool.
Cool's a good word. So now you don't have to worry about the size of the graphics card fitting in your case as much because the water blocks are significantly smaller. But you do have some other things that change as well. You don't have to worry about size, but if you were buying a graphics card for its RGB qualities, well, you're ripping that out because all of that's on the air cooler. And so you want to worry about what is the brand of the water block now for the RGB lights on it, and how do you want to make that management software work with what you already have.
And aesthetically, it's actually kind of interesting to see water inside a computer.
Oh, it's really cool when you do it that way. The other thing that changes is the color of the graphics card. If you're going to throw out the air cooler, there's no sense buying white for a white build because you're going to take it off the graphics card and put a water block on it. So you want to buy a white water block instead. And the final thing is compatibility. Make sure your brand and graphics card you buy has a compatible water block. You want to buy them at the same time because they have to be compatible.
And I would say it's not an easy task to do a water block, is it?
No, doing water cooling is a lot harder.
We're almost there. We have 2 more steps. The next one is to decide what GPU you're going to use.
By GPU now, we're talking about the graphics process unit on the graphics card. When you buy a graphics card, you're buying 2 brands. You're buying a brand of GPU and you're buying a brand of graphics card. It's kind of like when you buy a PC. When you buy a PC, it may have an Intel CPU or it may have an AMD CPU, but there's a brand too. It's an HP PC with an Intel CPU. Once you pick the GPU's brand, then you got to pick the GPU's generation you want, and then you want to pick the performance tier within that. Here's a table, for example, of the NVIDIA chips. Their GPUs are the 4060 all the way up to the 4090. Some of them have the TI afterwards, which just means it's a more powerful version of that performance tier. But within it, you can see the number of cores, the boost clock, the base clock, the memory. This helps you to pick one. You now know, do I need more memory? Do I need more speed? The power connectors, the power supply requirements, and even the monitor requirements. Will it support what you need?
The 10th and final step is shopping on Amazon for your graphics card.
What I do when I search for a graphics card on Amazon is I search with the phrase of graphics card, then I put the manufacturer of the GPU, so like NVIDIA, put down the performance tier number. That makes it so much easier. Then I put the amount of memory I want, like 8 gigabytes. If you know you need a brand, you put in the brand.
Now you're ready to pick your graphics card and make it fit in your budget.
And that's it. That's all you need to do to pick a graphics card. Thanks for watching. Please subscribe to see more in this series.
And give us a thumbs up if you liked the video.
Thanks, guys. Bye.
Thanks. Bye.